Okay, welcome back everybody. Happy Friday. Here's our look at the calendar. Today we are going to finish up rational functions. We're just going to continue what we had done last time. Coming up next week, Monday is just an ordinary day for us. On Wednesday, quiz number 3 is due. I'm going to hand that to you on Monday, and it's a take-home quiz just like all the others, and so you'll work on it. Give it back to me Wednesday. Wednesday coming up is the day before Thanksgiving, and it is an ordinary day here at GCC, and we will meet on Wednesday afternoon at the usual time, okay? And it is really important that you show up on that Wednesday afternoon, even though it's the day before Thanksgiving, because that quiz is due. And if you don't hand it to me right then, it's a 0. I didn't intend for this to happen. Like, this wasn't me saying, hey, this is how I'm going to get them to stick around for the day before Thanksgiving. As you recall, our calendar didn't look like this until I changed it last class, because I thought we just needed a little bit of extra time to sort of get caught up, okay? If for some like family reason you absolutely cannot be here on Wednesday afternoon next week, you better get this quiz to me before you leave, before you go wherever you're going, okay? So it is due at the start of that class on Wednesday. And then we're off next Thursday, Friday of next week. All right. Questions on the calendar? Trevor? I suspect evening classes are canceled on Wednesday. Friday, Thursday. Yeah, I don't see anything here. I don't think we have Wednesday evening classes for before Thanksgiving. Other questions? Okay. All right, so here we are on page 50. All right, so we have replaced the original function with this monstrosity that I've given you. I believe this example is harder than anything I will ever actually give you on a test or a quiz, but it includes everything you could possibly hope to know about a rational function. So I thought, why don't we just do something really tough? And if we can get this, we can get anything. So we're going to give this a shot. The goal is simply to graph this thing right here. We're going to follow a process that we didn't read last time, but it's here on the previous page. I'm just going to run through it real quick. You don't need to go back here, but first step is to fully reduce the rational function. The next thing is about symmetry. To be honest, I'm not really a symmetry guy, so that's not super important to me today. We're going to find a y-intercept. We're going to find x-intercepts. We're going to find vertical asymptotes. We're going to find horizontal asymptotes. We're going to plot a point in each of the spaces that we've created. We're going to have like a shell created by dotted asymptotes and some intercepts around. We're just going to make sure we plot enough points so that we know whether the function opens up or opens down, right? Just barely enough to get the last piece, and then finally connect the points using the asymptotes as a guide. So this is the process with a little more detail there than I had just said. So let's come down here. The first step we just saw was to reduce completely. So in order to reduce this thing, we need to factor all of these pieces. So that is what we're going to do. We're going to do this quickly, quicker than some people are going to be comfortable, but you can take your time factoring when you're doing homework and the activity. But let's see if we can do this kind of quick. First thing, what can we factor out of the first parentheses there? Yeah, there's no x in this last guy. What number can we factor? 3. And for me, I like my x squared to be positive, so -3 is going to come out of everybody. So pull that -3 out. X squared plus 2x minus 8, is that right? Okay, and then I'm just going to copy everything else because the rest of the factoring is all similar. There's nothing else we can factor out of all the other ones, so factored out the greatest common factor in the one place we could, and then there's nothing else to do with that kind of factoring. Okay, but now we get to the factoring of trinomials, so -3, and then we're going to get 2 parentheses for this first trinomial. So again, this is the part that some of you guys are just like beasts at, and some people need to take more time, and it doesn't matter to me which one you are, as long as you can get there. But I'm going to ask the beasts to just sort of zip us through this process right now. X plus 4, x minus 2, is that all right? I'm going to highlight that's this guy is now there. Okay, and then the next one in the numerator, x plus 4, x plus 1. Highlight that guy and that guy. Again, if this is too quick, don't sweat it. You don't need to do it that quick. But I want us to get to the punchline, and we got to get through this factoring first. Okay, the next one in the bottom. Oopsies. +4 minus 3 sounds good. So we'll highlight that one is that one. And then the last one. Okay, I've run out of highlighters, so I'm just going to say this one is this one. Okay. So for factoring trinomials, you might be like a 2x2 box person. It takes time to do the process. So don't worry about the time component there. But now that we've got all the factors up here, let's make sure we're solid on the rest of the process. And it's still a long process. Okay, so before I do any reducing, I'm just going to make a note right here and right now that, what do we call these things? The restricted values, is that our name for the things that we can't plug in for X? Is that the phrase? Restricted? Yep. Oopsies. Okay, restricted values. So I'm just looking for values of X that make the bottom equal to 0. The first factor, -4. Second factor, 3. Third factor, 2. Fourth factor, also 2. We don't need to write it twice. Okay, so those are the restricted values. And at each one of these restricted values, there's something special that's going to happen on the curve, and there's only 2 choices. Either it's a vertical asymptote or it's a hole. Those are the options, okay? And so in their process, we got to decide which ones are which. Our next step is to reduce as far as possible. So let's do that now. What do we see that's exactly the same top and bottom? X plus 4, that goes away there. What else? X minus 2, that goes away there. What else? That's it. So we've reduced as far as we can, and I'm just going to recopy everything that's left over. -3, X plus 4, X plus 1, over X minus 3, X minus 2. Okay, and I got to say that this thing right here is a whole lot simpler looking to work with from my vantage point than the original monstrosity that I gave you, right? So definitely in our best interest to simplify as much as possible. Okay, so I think we're in a good place right now to decide which ones were holes and which ones were vertical asymptotes. How about X equals 3, which is still in the denominator? So is it a hole or is it a vertical asymptote? It's a vertical asymptote. If you cannot plug X equals 3 in, it is a fundamental problem. And the fundamental problem, like a hole is just a little teeny tiny problem. It's just a blip on the radar, right? But a vertical asymptote is something where your function blows up to infinity and or down to minus infinity. That is a fundamental issue, right? And so X equals 3 is fundamentally a problem. It is a vertical asymptote. X equals 2 is a vertical asymptote. X equals -4, which was in the denominator but then disappeared, is a hole, right? Small little problem. Hole. That's the name. Okay, so let's get our conclusions here. All right, so we got vertical asymptotes. We said at X equals 3 and also at X equals 2. And then we said there was a hole at X equals -4. Good. And so I'm ready to start putting some dotted lines, dotted vertical asymptotes on my graph. So X equals 3 and X equals 2. Dotted lines at both of those. X equals 3 and X equals 2. Okay, I want to put my hole at -4. What other piece of information do I need before I plot the hole? I need the y, right? All I have is the x. It's at X equals -4, but where is it? Is it up high? Is it down low? Somewhere in the middle. We got to find the y. Yeah, we got to plug in the -4, but you got to be really careful because if you try plugging -4 in to this thing, for example, then what happens? You get 0 in the bottom, which is no good. So where are we plugging -4 in? Is the last one. It's the only place where we're allowed to plug -4 in. So plug -4 right in there. Okay, so I'm going to write something that is not true, and then we'll fix it. F of -4 equals by plugging into this last simplified thing. So we plug -4 up on top. Let's see, it's a -3 there times some parentheses divided by some parentheses. Good. You could, I'm content to do it in the current form. When you plug -4 in for x in the first parentheses, what do you get? 0. Okay, that's interesting. Next one. -3, bottom one. That's a -4 for all the x's. -7. And last one. -6. So upstairs, 0. Downstairs, hardly matters. What is this equal to? 0. So that means that the location of the hole, what, comma, what? -4, 0. Good. Okay, so I don't like lying to my students, but I prefaced this and said this is not true what I'm about to write down, so we need to fix it a little bit. But where did I lie in that line right there? The arithmetic is all good. No mistakes there. How did I start this calculation? What did I write? No, I think the x plus 4 goes to 0. That part's okay. What did I label this thing before we actually started doing the arithmetic? F of -4 equals. That's the first thing we said, right? We were being good mathematicians using proper notation. What's the problem with saying F of -4 equals? If we had plugged into any of the previous versions of F, what would we have gotten for F of -4? Undefined, right? We intentionally didn't plug it in here because it's undefined. Well, just because we're allowed to cancel doesn't magically mean all of a sudden we're able to plug -4 in. So I don't quite know, like there's no proper way to do this. I don't know, not really. I mean, like it's undefined, but we gotta find the location of the hole, and this is how we do it. Okay, so we didn't do anything wrong. It's just like a syntactical, like notational thing. And if you write this, I'm not taking any points off, but I gotta say that F of -4 is not 0. It is undefined. Okay, so let's plot the hole. -4, 0. Put an open circle at that point. It's not super important to me how you write the, like F of -4 piece, but for sure it's important to me that you put an open circle right there at -4, 0. Okay, so we've got the hole, we've got the vertical asymptotes. Let's go ahead and find the horizontal asymptotes right now. If you recall, the horizontal asymptotes had to do with the degree on the top and the degree on the bottom, highest powers that you see. So there's lots of different versions of this thing. I'm happy to go down to my bottom, most simplified version. I'm going to write this here sort of informally. If I distribute on the top, FOIL the things together, I'm going to get x squared plus some stuff. And then there's a -3 in the front. So if I distribute that, it's going to be -3x squared plus some stuff. Yeah. And the reason that I feel okay being really informal here is that the only thing that we care about for the horizontal asymptote is the leading term. Anything that isn't the leading term is inconsequential as far as the horizontal asymptote is concerned. Downstairs, what is the leading term? It is x squared plus some stuff, okay? And so you recall last class, we talked about horizontal asymptotes, and we said, oh, okay, if the higher power is on top, there was none. If the higher power of x is on the bottom, then y equals 0 is the horizontal asymptote. But if the highest power on top and bottom are equal, then we just basically cancel the x's and look at the leading coefficients. Which case is this? is equal, right? There's not more x's on top. It's x squared on top and x squared on the bottom. And so essentially I'm just saying, okay, I'm just going to cancel those x squareds and say -3, that's my horizontal asymptote. But I'm really going to insist that you give me equations for horizontal asymptotes and vertical asymptotes. Is it x equals -3 or y equals -3? It is y. It's a horizontal line. Y equals -3. That's good. So the horizontal asymptote with a lot of analysis and hardly anything written down is y equals -3. And armed with that, we go back to the graph and we put a dotted line at y equals -3. Okay, next up for us, we're going to do some intercepts. By the way, the order in which you do things is sort of up to you. Like you just have to simplify first. And then after that, if you want to do asymptotes like we did, great. But if you wanted to do intercepts like we're about to do, that's fine too. Just got to get all the pieces down. On the test or quiz, I'll make sure like parts A, B, C, and D, I'll remind you, okay, give me vertical asymptotes, give me horizontal, give me intercepts. Okay, so let's find some intercepts. First, we'll find the, let's do the y-intercept first. We let what equal what? Yeah, we let x equal 0, which means really we're finding f of 0. You can go to any version of f that's on your page. I like to go to the most simplified version, so that was the bottom one. So when we plug 0 into that bottom one, -3, and then 4 parentheses that we're filling in here. I can't get this on the screen here. When we plug in x equals 0, what do you get in the first parentheses?
0 + 4.
Yeah, 0 + 4, so that's a 4. When x is 0, then top right parentheses, 1, bottom left, -3, bottom right, -2. Everybody okay with those numbers? We're just plugging 0 for all the x's. I can't get it on my screen, but you got the simplified formula on your page. And so we crunch some numbers here. Is that -2? Yeah, I got 3 negative signs here. Yeah, don't forget that first one there. Okay, so that means what comma what? 0, -2. That is the y-intercept. We can plot it right now, 0, -2. 0, -2 is here. Okay, next up, x-intercepts. X-intercepts happen when what is equal to what? Y is equal to 0. So what we're after is making the entire fraction. I'll scroll up for a second. What I really want is this whole thing right here equal to 0. Y is supposed to equal 0. I've got a fraction equaling 0. To make a fraction equal to 0, which piece is the one that we want to equal 0? It's the top numerator, right? It's not the bottom equal to 0. It's the top equal to 0. That's how you make a fraction equal to 0. So we're going to set the top equal to 0. I'm just going to write that top part down below. Zero equals -3, x plus 4, x plus 1. Everybody see it? Ignoring the bottom completely. And the nice thing about all the good factoring work we did before is that it makes this really easy. How much is x to make the first parentheses 0? -4. What x makes the second one 0? -1. The -3, a lot of students don't like that we ignore it. Well, we don't really ignore it. We say, okay, what x makes -3 equal to 0? None. There's no x that I can possibly pick that will make the -3 give me a 0 as an answer. So we look at it and then disregard it. Okay, so that means that we've got 2 x-intercepts. I like all my guys to have ordered pairs. First one, what comma what? -4, 0. Next one, -1, 0. And so we're going to plot those 2 x-intercepts. Yeah, something funny happened. What happened? The negative 4, 0, we've already plotted. Why did we plot it before? Because it was a hole. Okay, it happens. You don't need to plot it again. I mean, it's there. It's in the right location. So the only new one is the negative 1, 0, which is here, filled in. Right, it's just an ordinary old point. Don't fill in the other guy. It's definitely a hole. Good reason to do the holes first before you do anything else. Okay. I think that we've done all of the fundamental calculating that we can do ahead of time. All that's left is sort of put all the pieces together. I'm going to draw some stuff that I do not want you to draw. Let's go here. Okay, I know that in the left-hand space, I need to get close to this horizontal asymptote. So it's either going to be here or here, okay? Those are the two options. And I know that it's supposed to hit that hole. So which one do you think it was? Well, the top one, right? And the bottom one is going the wrong way. Okay, so we picked the top one. Still maybe don't quite draw it until we've figured it all out, or maybe you can draw with an eraser, because I'm going to be doing a lot of like drawing options and then erasing stuff that wasn't right. Okay, so now I've got this interval between negative 4 and negative 1, and I need to know whether it does this or this. And to be honest, I don't have enough information right now to know which one that is. Right? It could be one. It could be either one. And so what are we going to do? Well, we're going to pick an x between negative 4 and negative 1 and just find where the point is. If we find that the point is up here, then it was the top one. If we find the point down there, it was the bottom one, okay? So we got to do some calculating in here. I'm going to come back to that. After we hit at x equals negative 1, that x-intercept, the next point that I've got plotted, the only other point I have plotted is which one? Is that y-intercept, the green point. And so I know definitely it's got to hit that y-intercept. And so it's going to hit that x-intercept and then come down and hit the y-intercept. And you got two choices, because the next important thing, the next important behavior is this first vertical asymptote. So either we go up to infinity or down to minus infinity. But given that we've already seen that for sure it's going to go from the orange to the green, which one of these two do you think it is? Right? I mean, we're heading down to minus infinity. We're just going to follow it. It's just going to go down to minus infinity. So I'm feeling good about that piece. So I'm happy to erase this piece here. Yeah, Aaron. So when was it again that? Yeah, so it's just a common misconception that some folks have that graphs are not allowed to cross their horizontal asymptote. It's just not based on anything. The only thing that the horizontal asymptote cares about is the far left and the far right, and all it needs is for the graph to get close to it at the far left and far right. But there's nothing restricting a function from crossing over its horizontal asymptote. In this case, it does. Does that mean at the far right, it will. Yeah. At the far right, it's going to come back. Yeah. Okay, let's take a look. The next space that I see is between these two vertical asymptotes. That is a tiny space, but the graph lives somewhere in that space. Again, don't copy this, but here are some options. It could go up from minus infinity, come down to some spot, turn around, and then go back up, right? Could do that. It could, I'm going to run out of colors here. It could be up at minus infinity, come down, and then continue on, and then down to minus infinity, right? Start at infinity, down to minus infinity. It could have started down here at minus infinity, gone up, and crossed right over and up to plus infinity. Yes? What's the last possibility? Start down, turn around someplace, and end down. Right? It's one of those four. Okay. All that we need is at one point. One single point in that little space is going to tell me which of the four options it is. So I'm going to erase these in just a second. To be honest, two of these we know for sure are not possible because two of them went right through the x-axis. Yes? How do we know that can't happen? We would have had another x-intercept, right? We found all the x-intercepts. And if this graph that's in black here had really hit the x-axis there, we would have found that point first. Okay, so it's not either of the crisscrossing ones. It's either way up or way down, and just a single point is going to tell me which one it is. So I'm going to erase these things in here and know that we got to figure out whether it's up or down. Okay, and then on far right, again, two possibilities. So either up to minus infinity near that vertical or down to minus infinity. up to infinity, down to minus infinity. And then as Jamie says, you know, does it have to get close to the horizontal asymptote at the far right? Yeah, it's got to be really close to the asymptote on both extremes. So either there or there, okay? And without much work, I could start to see, I would just have to connect the pieces, right? Like it could be that, or it could be that. I think it's just one of those two, right? Those are the options. We are gonna find another point out here. But to be honest, we actually have enough information right now to know whether it was the top guy or the bottom guy. Why can't it be the top guy? There would have been another X-intercept, right? It just can't be. So without any more points, I know it's going to be this bottom guy. Okay, so I think we've got all the pieces that we want. All that we need now is just a few extra points, and then this one will be in the past. I think there were only a couple of spaces we needed points. One of them was between -4 and -1. So how about we pick a number between -4 and -1? -3. And then the next space was this little teeny tiny interval here between the 2 and the 3. 2.5 is good. And finally, the last one, anything out there after 3, 5. Okay, so let's split up the work here. These two tables are finding f of -3. These two guys here, f of 2.5, and the two in the front, you guys are finding f of 5, okay? For the whole number, folks, not the 2.5s, I think it's easier to do this without the calculator, honestly. So just do it by hand. Plug into the simplified version. The 2.5 people, you guys might want to use the calculator. All right, so let's come back together. So we've got all our numbers. I think we've got enough agreement here that I feel good about these numbers. So all we're going to do is plot these 3 points and then finish with our graphs. Okay, f of -3 is 1/5. Just plot it. F of -3 is 1/5. Put that in black here. -3 is 1/5. Right in there, just a little bit above the x-axis. I think that narrows it down, right? Was it the top one or the bottom one? It's the top one. So I'm just going to erase. You're welcome to now start drawing this guy in. So we're erasing the bottom guy, and I'll update the top guy. It looked like the top guy, but I didn't quite know where it was. So something like that. This was -3, 1/5. Good there. Okay, f of 2.5 is somehow up at 273. It happens. F of 2.5 is 273. Okay, not to scale. Plot that point. Not to scale. So we're going to 2.5, and we're going up to 273. I'm going to call it right there. This guy, I'm going to say, is 2.5. I'll put quotes around my 273. Good. So remember, we had decided that in between these asymptotes, it was either like both ends going up to infinity, a really narrow like smiley face, or a really narrow frowny face. Which one did we just discover? That is a very thin smiley face going down, hitting that point and going back up. I cannot guarantee that that point is actually the bottom of the smiley face. We don't have the tools to do that, but it's up there. It could be lower. Maybe the bottom point is really at 2.4. I don't know. All I have is 1 point up there. To find where the bottom really is a calculus question. Okay, and then the last one, f of 5 was -27. So we plot that point, again, not to scale, f of 5, -27. I'll erase what I had here. So 5, -27, 5. And then I'll put quotes around my -27. And so I think that means that it was that bottom of the two branches that we drew. So down to minus infinity, and then coming in very close to the horizontal asymptote. All right, these problems are no joke. One problem took us about 28 minutes. But we did a lot of discussing and figuring, and it's, you know, it's a process that once you follow a few times, it gets quicker. So I actually hadn't done this ahead of time, but let's just see. Let's just see how what GeoGebra thinks about graphing this equation here. Okay, so we're going to make it so we can see it a little better. All right, so I need somebody, and then we'll get the grid going here. So I need somebody to read me the original thing, f of x equals. Okay, so actually, it's a good question. Where? Here? I'm just trying to. I made the font so big that we can't actually see the thing anymore. Okay, so Chris recognized that I didn't say anything about this, but I put 2 parentheses down at the bottom. I put like this extra parentheses here in the beginning, whereas I didn't on the top. So it turns out you don't need them on the top, although it's probably safer to just put an extra set of parentheses on top and the bottom. But for sure we need it in the bottom, because the way that this original problem was written, like we can look at this and know that both of these guys are in the bottom because of how we write that fraction line. But GeoGebra doesn't know that, right? And so we need to put in this extra parentheses right here to say, hey, both of these things I'm about to tell you are in the bottom. Yeah, but it turns out we don't need it on top. All right, how does it look? Not satisfactory yet. Okay, hang on. So let's pull some stuff around. All right, so how did we do on this side? Approaching what number on this side here? Approaching -3, what do we think? That's pretty compelling, right? I mean, it's not at -3 yet. -3 is this line here, but if I keep pulling in, yeah, it sure looks like it's getting darn close to -3. Okay, how did we do here at the x-axis? What did we say was here? It was -4. And in fact, we said there was a hole there. Now, I don't know if GeoGebra has the wherewithal to like plot a hole. I mean, to me, I just see like a continuous function there. But we know better, right? There's a hole there. Okay, and then, all right, so then it came up, and then it maxed out somewhere, I don't know where, and then it came down, and then it hit, what was the x-intercept? Was it -1, so that was correct. And then didn't we have a y-intercept too? -2, all right, I can see that right there. And then what was the vertical asymptote that we ran into? Was it x equals 2? And so if we keep pulling, and keep pulling and keep pulling, all right, what do you think? Starting to look like we're hitting at -2. Okay, what was happening between 2 and 3? There's a big smiley face. Where is it? It's supposed to be up here. Where is it? Weren't we up at 270 something? Yeah, okay, it's just not there yet. We just got to keep pulling. Ah, okay, now we got it. We're dialed in there. Okay, so asymptote here at 2, next asymptote at 3, and in fact, yeah, it's really thin smiley face. Jed. Yeah. 4 or -4? Into the first one? Yeah. 4 or -4? -4 is what you want. Scaring me back there, Jed. You're gonna break the rules of mathematics. Okay, and then on the other side, I think we just had this, right? We had wasn't it down at -infinity on the just to the right of that vertical asymptote? And then what was the horizontal asymptote to the right? 3. Okay, I can't tell that we're leveling off at 3 here because my scale's messed up. But you know, I mean, this is one of the benefits of GeoGebra is that you can just mess around with the scale. Okay, so now I can see. Let's keep pulling here. So all right, now I can see -3 there. And if we pull this guy in, we're hoping that we approach -3. What do you think? That looks pretty good. All right, and you know, I mean, just to give us a sense of how complex this problem is, I can't get like a single picture that's going to capture all of the behavior, and this is sort of what the previous project was about. It was like, give me different views because it's too complex to see everything important in one picture. And that's what we saw here. Right? And that's why on my graph, I had to put quotation marks around 273 and negative 27, because it's just too much information to display in one coherent picture. All right, so what you are going to do is just follow the steps that we did there. They are written out for you here on page 49. The group activity is right here, starting on page 51. The group activity is 9 questions. I'm going to take part of the group activity off of your plate. This last sentence here you can ignore. Ignore that part right there. But everything else you got to do. So let's see how far we can get.